Hello and welcome. My name is Chirag Dave. I'm a Senior Database Specialist Solution Architect here at AWS. And I'm here to talk to you about some of the operational best practices when it comes to RDS for Postgres and Amazon Aurora Postgres. So when we talk about some of the best practices, I would like to cover these important topics that includes monitoring, connection management, high availability, security, backup and disaster recovery, and database tuning. Now this talk is at very high level, but I'll make sure that I add some relevant link in the description section. So let's get started with monitoring. So now let's talk about operational monitoring. So when we talk about operational monitoring, both RDS and Aurora Postgres comes with many tools and features. So let's start with Performance Insight. Amazon RDS Performance Insight is a monitoring and tuning feature in RDS which helps you assess the database load and determine when and where which action to take. It makes it easy to visualize SQL statements that are causing the load and more importantly tell you why. You can certainly visualize the database load and filter it by wait events or even by SQL statement, host, or the users. It uses a lightweight collection method, so enabling it will not cause any database performance. And you can keep this data 7 days for free, or you can choose to increase up to 2 years. And more importantly, you can integrate Performance Insight with a third-party tool. You can connect it with using APIs and SDK, so that it helps you to connect with other third-party tools. So let's head over to the UI and have a quick look at it. So when you log into Performance Insight, you can see that it's really divided into 3 sections: the counter metrics, the database load, and the top dimension table. Counter metrics is really showing you data for a specific performance counter metrics. So depending on your engine, you might have some default metrics that are displayed. However, in order to change any of these performance counter, simply click on Manage Metrics. And here you can select multiple of either the OS metrics or the database metrics. And to see the detail of any of these metrics, simply hover over the name of the metrics and it'll show you the description. Now let's look at the next section, which is one of the most important section, which is the database load. So under the database load, it's really showing you how the database activity compares to the DB instance capacity. So in this particular case, I have a virtual machine, or my instance is of 8 vCPU, and you can see that all of my activities under the 8 vCPU. So it's really trying to show you the DB load sliced by the wait time, as you can see it here. You can always change that slice by wait time or an SQL. And last but not least is the top weight or the top dimension table. So the top dimension table slice shows you DB load by different dimension. You can either look at it by top SQL, top host, top weight, etc. So one of the powerful features of Performance Insight is ability to view this data in a different dimension. So for example, if you're interested in understanding all the queries which are waiting on IO wall write, so you can click on IO wall write, and on the bottom of your screen here under top SQL, you can see all the SQL statement which are waiting on IO wall write. Same thing, you could do it in the reverse way. You can view the data of your database load sliced by SQL, and then you can click on the query of your interest. For example, let's say I'm trying to click on vacuum, and you can see that which wait is being triggered by this particular command here, and you can see the top weight for the vacuum is CPU. Now let's talk about enhanced monitoring. With enhanced monitoring, you can monitor the operating system of your DB instance in real time. So for example, if you want to look at which process or which thread is consuming CPU or the memory, enhanced monitoring can be extremely useful. The metrics are collected in 1 second interval, and you can get up to over 50 CPU, memory, file system, and a disk level IO metrics. And you can view all of these metrics right in the RDS console. It's really like running a top on your system. Let's move on to the next one, which is Amazon CloudWatch. So with Amazon CloudWatch, just like in Enhanced Monitoring, you can view these metrics right in the console, or you can personalize a CloudWatch dashboard. With the CloudWatch metrics, the metrics are collected in a as low as 1 minute interval, and the metrics we collect are CPU utilization, storage, database connection, I/O related metrics, latency, throughput, replication lag, and so on and so forth. And one of the important features of the CloudWatch is the CloudWatch alarms. So you can set up an alarm and trigger an action based on metrics when certain thresholds are met. So again, very important service when it comes to monitoring and thresholding. And it's really the key difference between the Amazon CloudWatch and Enhanced Monitoring PI is that the CloudWatch collects the metrics on the hypervisor level, while the Enhanced Monitoring and the PI collects the metrics from the OS kernel. So that's exactly similar to how if you were to run top or the VM-stat on your EC2 instance. Let's move on to the next one, which is the event notification. So Amazon RDS uses Simple Notification Service, or SNS, to provide you a notification when certain RDS event occurs. So this notification could be in the form of email, could be a text message, or even the HTTP endpoint. So really, anytime there's any change that happens in the DB instance, or when you take a snapshot, or you make a change to a parameter group, or in case of Aurora, if you're making a change to a DB cluster or a DB cluster snapshot, you can get notified. So this could be extremely useful if you want to track all the changes, and if you're very security and compliance sensitive, this could be extremely useful. Next is the Postgres logs. Again, this is true for both RDS and Aurora Postgres, that if you have a proper configuration in your parameter group, you can have a lot of good information in your Postgres log that includes slow query duration, auto vacuum related information, checkpoint related information, logging the temp files, and explain plans if you have enabled auto explain extension. So Postgres logs are available in console, or you can push them to a CloudWatch. So again, a wealth of information do get logged, and you can use that in your as operational best practices when you have to debug any performance issue. Last but not least, speaking of performance and the troubleshooting, if you want to go at much more granular level, Postgres does expose a bunch of catalog tables, such as pgstat user table and indexes, pgstat IO user and indexes, pgstat BG, pgstat database, and pgstat BG writer. So pgstat, for example, pgstat user table will give you information about, for every table, how many sequential scans were done, how many index scans were done. It'll give you some approximate size of a table, when was the last time vacuum or auto vacuum was run, when was the last time auto analyze was run. So it gives you a lot of these low-level details in a very easy way to consume. Same goes for stat IO, where it gives you a little more information about the IO, how much IO was used on a certain table or index. PG stat database, it's much higher level on the database side, so you can see how many commits or rollbacks were done, for example. So good information on the pgstat database as well. And pgstat BG writer is somewhat more specific to RDS Postgres, where if you want to look at how often the checkpoints are happening, how is the background writers working, so there's good information around background writer available in that catalog. With that, we will move on to our next topic, which is connection management. So connection management, just like any other database, is really important, especially when it comes to Postgres. So when it comes to connection management, two things are important. You want to limit the number of connection going into your database, and you want to limit the number of active or concurrent session running in your database. Now let's try and break it down. So if you have application is when it needs to connect to a database, every time you open and close connection, what you can happen is every time you open and close connection, there is a cost associated with this in terms of CPU cycles. You want to avoid that. And more importantly, if you open a database connection and if you leave those connections unused or idle, again, there is a cost associated with it in terms of memory. There's some set of a memory get assigned to every connection in Postgres. In doing so, you're wasting some of the memory there, which could potentially be used for other purpose like caching. So one of the recommended way is to use some sort of a client-side connection pooling, where you set your min and max connection and avoid opening and closing connection. Well, that works great, but as you start adding more application server, assuming you're running application on your container platform, and as these containers scales up, what's going to happen is every application server is going to make n number of connection, and now you are throwing many connection to the database server, a lot more idle connection, and could potentially causing more concurrent active session. One way is to use some we call it server-side connection pooling. One of the things you can use is the RDS proxy. RDS proxy is the managed service which works with Postgres and Aurora. With that, you can control centrally how many connections can connect to the database, and these connections can get reused as well. So highly recommend to check out RDS proxy, and if you want to use some open source route, PG Bouncer is one of the recommended connection pooling in Postgres. The other couple of the recommendation would be to leverage the timeout property in Postgres, like query wait timeout and idle transaction timeout. And also you can look at some of the statement timeout or idle in transaction session timeout. Moving on, let's talk about high availability. Now I'm going to break this down into first for RDS Postgres, and then we'll talk about Aurora Postgres. So the recommended best practices in RDS Postgres would be to run your production workload in a multi-AZ mode. So you have a primary running on one AZ, and you have your replica or the secondary node in another AZ in a synchronous mode. You cannot use your secondary for querying. However, behind the scene, the data will be synchronously replicated, thus giving you very high availability. And to scale your reader nodes, we recommend to have an additional reader replica where you can forward your read-only queries. So that's specific to RDS Postgres. In Aurora Postgres, things works differently. In our Aurora Postgres, because we have a shared storage model, there is no replication going on per se. But the recommended setup would be to have a writer instance, of course, and then have more than one reader node which get attached to the same storage. And more importantly, you could have a dedicated reader node as a failover target, which you can set using priority 0, which will take whenever the failover happens, that node will get promoted as your primary node. You can use that, you can set this by setting the tier on your reader nodes. Other thing that you can consider is a cluster cache management. So when the failover happens, your data in your promoted node will be available or will be in sync with your writer node. The other couple of recommendations would be to lower the TTL or DNS cache on the application server. And if you were to use RDS proxy, you can see some significant reduction in the failover time, as we discussed in the last slide. And if you have a requirement to have a global cross-region read replica, then I recommend to check out Amazon Aurora Global Database. As far as the security goes, RDS does provide you with many features and capabilities when it comes to security. So the first one is you want to make sure that anytime you connect to the database, you make sure that you connect over SSL. And the way you could do it is by using RDS force SSL equals true. That will make sure that your connection to the application, from the application to the database server, is encrypted. So that's encryption. That's your encryption in transit. In order to control who can connect to the database, you can leverage security groups. Basically, you're defining in the security group which application server is allowed to connect to the RDS instance. So important to restrict who can connect or from where they can connect to the RDS database. AWS identity and access management. Again, a very important critical service within AWS ecosystem, which allows you to define policies to assign permission and determine who is allowed to manage your RDS resources. So make sure you have proper policies defined in IAM, so that way you can control who has access to your RDS instance. All your RDS data and even the snapshots are encrypted by default. But again, if you choose to provide your own key, you can certainly provide your own KMS or key management system keys to encrypt your data. Last but not least, if you are trying to change the password, normally you will update the password by using alter role. One of the security gap here is that when you run a command alter role with a new password, that password get logged into your Postgres log, and that could be a security vulnerability. And you can avoid that by using a command that I've shown in the slide here, by doing an inline using the -c command. Something that it's important to avoid putting some clear text password in your Postgres log. And last but not least, starting Postgres 13, we support SCRAM-based password authentication, so strongly encourage using that. And last, we'll talk about backup. So again, some of the operational best practices around backup would be, it's highly recommended both in RDS Postgres and Aurora Postgres to keep your backup up to like 4 weeks or a month. Again, based on your organization need, but it's highly recommended to have some sort of a monthly backup retention, so to speak. So if you ever need to go back to any of the point in time, you can. Other than that, it's also recommended to do a periodic logical dump. Remember, when you do an automated backup, they are more on the storage level, they're more physical backup. But you can certainly use pgdump, which is a native Postgres tool, to dump specific tables. You might have some few important tables you want to take a dump off. You can certainly use pgdump as a logical, and you can export that to S3. I want to call out another important service called AWS Backup. So what AWS Backup will do is it will centralize your compliance and policies control in the backup, and it will increase your security choices for your organization. So with AWS Backup, you can centralize which database to backup, what's your retention policy, when to run backup, and so on and so forth. So it's a centralized service that you can use that to your advantage to backup both RDS Postgres and Aurora Postgres. Last but not least, both RDS, Aurora, and Postgres support S3 export. So right from the database, you can export. Again, that's another option for logical backup, just like pgdump, is to export data and using S3 export extension, and you can push this data straight to S3 bucket. So we have a lot of options for your disaster recovery planning as far as the backup goes. And as far as the tuning goes, it's going to be again very high level, but I do want to call out some of the key performance tuning parameters like shared buffer, maintenance work mem. That's the part of the memory that gets used anytime you're running vacuuming or creating index. Work mem is a setting that will be used anytime you're doing hash join or any kind of sorting. Part of memory that Postgres will use is work mem. Max wall size, something to consider, and again only applies to RDS Postgres. Checkpoint timeout, auto vacuum max worker, auto vacuum cost limit are again important ones, especially when you are trying to tune your auto vacuum. For the large table, auto vacuum has a default settings, which is a threshold of n number of % of dead tuple. It'll start your vacuuming. However, if you have a very large table, in that case, maybe a 5% of default of vacuuming might not get to for a long time. In that case, your large table will not get a vacuum cycle for a long time. So you can also alter those tables and change the auto vacuum scale factor per table basis. That way you get to these large table, get to vacuuming sooner than later. So you don't have to change the global setting, but you can apply this setting per table basis. So these are some of the tuning parameters. Again, I'll be adding some more reference in the description section for your future reference. But that's all I had for today. Thanks for watching.